before we start, this is the drone use DatuBIM TopoDOT session. Should be very interesting. I'm very interested in seeing what they've done because I believe this is the future, if it's not really already here, on how we're going to complete projects. A couple of announcements. Make sure you signed in at the desk. Download the event app, Crowd Compass Events. If you haven't already done it, that's how they really want you to do the session evaluation, which gets your name in the drawing later this evening. Lunch will be from 11:30 a.m. to 1 in the grand ballrooms A and B. And don't forget the Wednesday night reception from 4:45 to 7. You should have a drink ticket in your badge. It's the pink one right there. Looks a little reddish orange to me, but it's pink. So without further ado, I will let Luke and Justin do their presentation.
Thanks everyone for coming out to see our presentation. I wanted to just kind of start with a little brief survey. If you guys, anybody flying here, raise your hand if you fly. Hey, we got one. Pretty new. So everybody new, fairly new to drones, just seeing mostly deliverables, pictures, photos, videos, different deliverables. That was pretty new. All right, well, we're gonna do some demos here and get into it.
One of the main uses for drones is safety. We're able to do anything that we do safer. We're able to take our folks off the highway and keep them out of harm's way. So that's one of the things we always like to point out in each one of our presentations. So one of the softwares we're going to go over today is DatuBIM. This is an example of what we're using DatuBIM for on a construction project in Pulaski County. We'll go through it. There's several aspects to this software that are kind of unique, and we've been very pleased with it.
So this pet project here, well, not pet project, it's their sample project here is Highway 80 and 461. It's been a perfect situation. We have a nice interchange and about a 4 mile in length project that we've been able to monitor for almost about a year and a half on a monthly basis. So essentially, we just went through and did little tutorials on how to do DatuBIM. And so after this, you should have a general idea of how to use DatuBIM. And we took it on a little sample project in a little sample rockfall project. I'm sorry, I actually stepped on that.
Yeah, this is a sample. We ended up using, I think, 23 photos for this just to kind of demonstrate how fast DatuBIM can work. This was a rock face that we had. We spent about 15 to 20 minutes in the field surveying for GCPs and flying it. So it was very little time. The video kind of here is going through just setting up how to get your outputs that you need for DatuBIM to work properly. It's pretty self-explanatory. I would say that if you can use Windows, you can use DatuBIM.
You can set up multiple users in there. You can associate it to where they have easy access to it. So if anyone has a license to the software, it's all cloud-based, so they can get in there and do all the views and analytics once it's set up.
So after you set your area up, you're going to add a flight to it, and demonstrating here how to do it. You select your images. Like I said, I think we picked 23 images for this particular example. It works just like all of our other softwares as far as for photo processing. Pix4D is very similar to the way that this works. You're going to put your date in. It'll auto choose your camera. Down at the bottom, you're going to select show that you're going to use manual GCPs, which you do have to mark on each one of those. But we'll get into that in a second. This software is perfect for construction monitoring. It's also perfect for sharing data. If someone's got a quick project, if they want to do like a landslide or anything, it's easy to share it. It's very user friendly, very easy for field inspectors to do on a routine basis. Sorry. But then you have to import your and mark your GCPs, your ground control points. We're having a little bit of technical difficulty. So once you have your photos uploaded, you'll import your ground control points, and through this, you're just using a traditional GPS survey. You have to change the file structure to meet the way they like it, but once you got them set up, you just pull them in. It's not cooperating. Yeah. It's starting to fly around. Sorry. But anyway, so you mark your GCPs. Essentially, you have at least 4 photographs per point. Birdie. And you do that through each GCP, and that's essentially geolocating all the photographs, and it'll go through and process the model from that. And you ever take about, for this project, it was 45 minutes to process the data, and you'll end up with this 3D model. And see if this demo works, and it is working. Justin added the birds, I might add. I'm just going to throw that out there. So one thing to note about this software, this is a cloud-based software, so you can essentially run it on anything. One of the situations that we ran into is, making sure your computer specs are up for running 3D modeling software, and that's not something that is a concern with DatuBIM. All right, so some of the other options that you can have with DatuBIM is you can upload your plans, all your line work, your 3D terrains, so your design file, your existing conditions, and we can go into some analytics. We can share in, we can actually see where we're on a project, where we are on where the right-of-way limits, the surge limits, alignments. It's easy to show, to do a field inspection with the data. So now we can see the whole project in a 3D model. Then we get into cross-section analytics. This is really handy with this software. It's all, you can just draw a cross-section anywhere you want to on the project. You can compare, it's going to automatically generate the cross-section for the date selected. And then you can go in here and add different dates. You can add the design file, you can add the existing terrain, and it's going to show you how it compares along your line. And there's a mobile application that goes with this as well, that your user could actually take on an iPad and go out on the project and walk through it and see exactly where they're at in comparison to those cross sections. So you get essentially better than station data. One of the other use cases is simply having that, how is it changing over time? You can compare whatever. So you set up your baseline, like that was June 3rd. You go in here and select to be whatever flight comparison you want it to be. And it'll put 2 maps, and these used to be 3D maps as well, on the screen, and you can see how it's changing over the course of your flight. This is a 1-year increase. Pause. It's doing it itself at this point. So how handy would it be to go up to a construction site or you're in a project meeting and be able to actually see how it's changed from the previous flight, to the previous meeting to this meeting, to be able to see how what construction's been done, where things have been moved at, where your stockpiles are. It's just having that time lapse is very beneficial. One of the use cases before we click on this video and keep going is creating the as-built contours and also some use cases for geotechnical investigations. When you have an instance where you have exposed rock faces,
you're able to go in and have those contours automatically generated from the terrain model. And you can actually see the contours and create the intervals the way you want them and see your rock lines. And the 3D model is amazing on the detail. And now we'll proceed to click on it before it terminates. So you have plenty of settings here. You can just play with the opaque, how visible you want them to be, your major, minor lines. You go in with your 3D model and you can actually see where your rock lines are hitting on what elevation they are.
And where it overlays the point cloud behind it, it gives you a real context of what you're looking at.
And if you find an issue on a project, being able to actually see it in a map and see it visually is worth millions of words.
So like Justin said, the time lapse is something that is this software really prides themselves on for construction monitoring mainly. With this project, we should have a flight every month from beginning to end, and that'll be exciting to put on a presentation to be able to show that.
Just a little video demo of it, the time lapse in action. And that's of course right at 1 year.
So a lot of times it seems like we get on those projects and we lose scale on how much it's changed over the course of the project. And this really brings it back and lets us see how much work's actually been accomplished.
Early on in the project for virtual public involvement, it's handy to show someone if you need to explain to anyone where the project lies within the construction sequence, where they're at, what stage they're at. This is an example here of one way we do it is using Pix4D and Open Roads Designer to create cross sections. It's a little more tedious, but it gets on a cross section. Versus DatuBIM, we can go in, and this could take probably basically a day to create the time you go through Pix4D and Open Roads to create those cross sections. Versus DatuBIM, once you have that model, it takes about a minute to create a cross section and compare it from the existing terrain to propose to whatever date you want to check within essentially 1 to 2 minutes, and then you can put it through cross section wherever you want to on the project. And every point on this cross section is active. So if you're hovering over it in real time, you can see the elevations for every single flight along that cross section.
So this goes back to the original example that we gave. It was a 2-acre site, 5-minute survey, 5-minute flight, 45 minutes to process, 1 minute for the sections and 1 minute for volumes. So that's, in my opinion, really, really good for a 2-acre site. Here's another benefit that we found with DatuBIM. It's just to be able to check areas. It was put to us that this is probably overuse of the software at some point, but we're able to go back and check like this grass area and measure that out for payments. We would also be able to check guardrail measurements and count a post. Obviously, that's a lot to use the software for, but we can use the software. That's not why we would use it, but we could use it as well. It's just a supplementary use. So that was kind of quick. Does anybody have any questions in regards to DatuBIM? We'll move into TopoDOT next.
So the surface that you're starting from, did you fly that before you started generating those cuts, you know, anything that you use the existing design file?
We got the design file given to us, but I think we got it after a couple of flights. We'd actually went out and just flown the existing conditions.
Yeah,
too.
you can have existing flight.
In that we did both essentially.
Yeah. And once you've got the flights, you can backdate them and add them in anytime you want to. It's and once you have that existing terrain, you can go back and add it at the end of the project. You need to add it, and then they're in there. We did this flight, the first flight, it had just been cleared. It was, so we got it right off the beginning.
So, yeah.
How accurate is it? You've got vegetation trees, higher grass.
It's going to be very limited because you have grass up here, you're going to hit that grass surface, and that's the survey you're going to get. The nice thing about these projects is once they're cleared, it's ground. The nice thing about this software is it does an auto, what they call 2.5D terrain, and it goes through and cleans out all the trucks and flattens everything. And we've done several checks on it.
And there's several ways to get around trees as well, depending on the angle of your camera.
Yeah, so
yeah, there's ways around some of that stuff, but high grass is going to be a limitation.
So, taking it a step further, thinking about these floods, I'm not going to have an ETM on the road, but I need to know how much the slide is. I mean, everything we got to do is going to be either verified with FEMA or with FHWA as far as distances, lengths, etc. And so my question is, you're going to fly after the event. So you've got road and then you've got a slide. Can we, in essence, back interpolate that? Maybe that be the next part you're moving in towards?
We can pull in the state plane LiDAR surface for that as well. So however often, do you know how often they update that? Every 5 years, we're going to have something that we could pull in for that's no more than 5 years old. So
you got a good terrain.
It's not what it is. I think we went to the Mayfield tornado, and we did something very similar with that, which kind of we pulled in state plane LiDAR off of Mayfield, and you're going to assume the buildings are look solid, so you're not going to get an exact I guess area of debris, but then when we flew it, the buildings were no longer solid. So it was a little bit of an error, but it was pretty close. We were able to do a comparison to the amount that was there before and the amount after. So FEMA could use that as a reference for the amount of debris that was left in Mayfield.
Any other questions? We can go back. There's a couple of those slides went pretty fast. We got one over here. Thank you guys.
Are the engineers using the DatuBIM much, or as far as checking their designs and things like that, or is it just for public?
In-house wise, it's just comparing. We're trialing currently. It's not anything on record. It's just, but we're using it to compare on truck counts in the field to see where they're at. Because that what they'll do is they'll go through and compare big areas and actually take the disturb limits. If you have the disturb limit shapefile, you can pull it in and use it as your boundary. So that way you have apples to apples with the contractor, but it's they're currently just kind of seeing how they're progressing and then comparing it, because at the end of the day, it's currently still truck counts on the construction side of it, but it's been hopefully it's going that route.
We're doing several things to check the accuracy just to make sure that we're spot on. We've worked with one of our local quarries to, they gave us a known stockpile and we went and flown it. They're adding something to it. We're going to go back and fly it again, and they'll be able to know exactly what they added to it. We're going to check that quantity versus that. So still a work in progress.
It's these slopes, you know, check the percent slope. It's easy on this versus having to walk up with a GPS or use a terrestrial scanner to scan it, and so we can check the slope compared to the design file at any point.
But one thing, this company's really easy to work with, so we could essentially give them our specs for what a slope can be, and they can give us a heat map, and we can fly that, and it'll turn red if it's bad or turn green if it's good. So that'll be super handy. That's one of the things that we've talked to them about working.
And that along that line with them working with us on progressing this software is an active center line where we have a 2D map or 2D line work in there. It's not active, but it helps guide us visually. But having an active center line to where we can click on it and cut a cross section at a known point to where it's a little more apples to apples with the PDFs cross sections will be very beneficial in the long term. But they're working towards that, and they have some great checking. And like you said, the cut spill is really coming along with your area and having that heat map of so we have 1 foot here or 10 foot on this section, or they went the wrong way, overcut. You have another question?
Are the software, are they charging you a monthly fee for that, or is it per flight?
It's the license of the yearly fee, and then it's photographs. They charge you per photograph. And I can't remember the number. It's like 8 or 10 cents per photograph. And they give you a big block, and it's unlimited, and you just have to maintain your license for it.
Which all the cloud-based processing software said is use the same payment scale.
And we're looking at getting to the point where it's the inspector on site would have a flight routine. He would fly it either on a needed basis when something happens, or on a weekly or bi-weekly basis.
Is that like 10 cents per photograph, regardless of resolution or size?
That's it was based off of 20 megapixels. Because we got a new camera after the process, after the contract, and it's like average 42 megapixels.
So it uses 2 photos.
So yeah, so it is technology. Yeah, we use an M300 with a P1 camera that's, I believe, 42 megapixels. Is what we process.
I'll ask the question. How does it handle processing like that undercut on something? Will that blow the software up, or see Nash? We got like that with transfers. Have y'all experienced that yet?
I wish I had it live. It's just haven't really experienced it, but essentially it's just a 3D model that we get. So the new method is when you create your terrain, there's a way to export the file that they want. And off the top of my head, I'm trying to recall the name of that file, but we had a lot of issues at first going through you pull the file out and have to go into Trimble and create it. Now they have where ORD can simply just export the file they need. I'm thinking it's like
it does
FBX, but it does work now. But it's just the terrain.
We flew an overhang section of US 60, and we were able to model that with them. So that's what the HSIB were wanting to document, was the overhangs to take those off.
But essentially, you'll have a 3D model of the whole project. And BREAKLINES all included in that terrain file that is exported out of ORD.
Any other questions?
Yeah,
Yes, sir.
You kind of just touched on it. So with this software, what kind of file formats can you export as? Like you were saying FBX. Are you able to get FBX files out of this?
This is just the export. I haven't, to be honest with you, we haven't looked at the 3D mesh shot on this one, but it will export the LAS file, and it'll export the ortho file, the map, the TIFF file, and the LAS. I know for a fact that it'll export those. I know on the triangle mesh, we haven't used this software for that yet. So I don't know the answer to that question on the 3D mesh side of it.
All right, well, we're going to move on to DatuBIM and how we incorporate those point clouds into ORD and DatuBIM.
Yes. So yeah, so TopoDOT's our next demo, and essentially we were able to virtually survey the TopoDOT, and we got a couple little. Okay, here we go. The first demo is a little quick tutorial on how to do CENTERLINE or DRAPE line work with TopoDOT. We created a little project, it was a little roundabout. Oh yeah, you can set it as a project. But we did I just took a little roundabout and using an example file, we ran through Pix4D, created a 3D point cloud, pulled it into ORD, and then we're starting to virtually survey it with TopoDOT. And this is a couple of tutorials on how easy it is to do. think this is the right one. No, this is not. Going through this, essentially you just draw your 2D line. There's a little trick on your whole control. It'll snap to the surface and you go to the other end of your point, snap to the surface. And then you set an increment at every 15 feet and it'll find the average. It'll give you an average elevation for that point within, you can set your box area like 1 foot by 1 foot, 6 inches by 6 inches. And then it'll set a point there and it'll create a drape line, just as if you went out in the field and surveyed down your center line, create that break line. So the next little thing is doing row shots. So once you have your center line draped in, TopoDOT is really handy to go through and survey your roadway. Not have to do a lane closure. So we've blown the project. We have, I mean, I bet there's 200,000-300,000 points just in that road section right there. And all we really need is a point every 3 or 4 feet from center line, and then a point every 15-20 feet down the center line.
On that note, that seems to be the main issue that we've had with sharing TopoDOT with other folks is our designers are used to, like Justin said, a point every 10 feet, a point every 15 feet, maybe 5 feet. And we're giving you a point every inch. And we give them that and they look at us like, what are we going to do? Use this for? This is not what we need. But TopoDOT's kind of giving us the ability to scale that back to more what they're used to. I mean, just with that grid system that it does, it generates such a smooth triangle mesh. And the contour lines are clean. You have your break lines in there. So here in a second on demo, we'll show you how to do the break lines. And along this line, I'm not sure if I did demo on it, on the ground shots, you can do the same ground shot, click an area wherever you want to in your project, and it'll give you a random, well, not a random ground shot, a ground shot over 15 feet, every 20 feet on the grid system that you want, and take a low point, an average shot. Like when you were asking about vegetation and tree canopy, this software will help pull out that ground canopy on the ground under canopy using like a low point mechanism that it does. That just get through. Yes, it is. Backing up in the presentation work well on our computer. We give it to them and it decides it has a mind of its own. So
John sabotages.
Yeah, what it was, blame it on John.
Perry's not here, so I can blame it on Perry. All right, so creating break lines through their extraction mechanism that they have, you can go through and so once you get your center line or some kind of line, you draw a line to reference off of. That's the one I wanted to skip again. There we go. So we have a reference line and it's basically giving us a cross-section view. And then we're on our beginning station and we can go in here. It's a little easier to see on the computer and you can change the density of this as well. It's colorized too, but we can find the bottom of the curve, top of the curve, the sidewalk, and basically whatever points that we want that are in a nice linear fashion. We can draw all our break lines in one workflow.
And if you do have something that's laying there that is putting your line out, you're able to adjust those points manually, so it doesn't affect your average. We found one that like a cone was laying there, just happened to be in the area, and you were able to go in and see that cone was there and bring it back down to the bottom.
I mean, you can, so you're just showing you can make individual adjustments. If your sidewalk widens in that between the zone, you can go in and change it. But just in a few minutes, you can have all your break lines for an intersection. I could do an intersection in 20, 30 minutes virtually surveying it. Once you get the hang of it, it's not too bad. It's like with anything else, practice, and there's tricks to everything. But yeah, it's a lot safer. This is so essentially we're virtually surveying, so we're not out there having to walk through have a lane closure or be in harm's way vehicle. Any questions on this while we're here? This video is still taking a few minutes. Any questions on TopoDOT?
Like our drone shot, we have a lot of potholes. Are you able then to highlight those potholes with different break line or different features so that you can kind of do a map if you're doing it in an additional mode?
Yeah, you should be able to go in and add some extra shots in those regions. But on potholes, you're going to want more data, and this is really getting it down into the surveying level. Surveyors are used to like 500 points at the most for an intersection versus we're doing millions. But using this, there is some mechanism with TopoDOT to get into those pulling or potholes. We're still just scratching the surface with TopoDOT. Like you were talking earlier, there's tons of features on doing extractions of like pole signs and stuff for the vehicle mounted LiDAR systems.
What kind of accuracy are you seeing? You know, if you shoot this in control on the ground, like when there's not a lot of contrast, like asphalt, how tight are you getting?
I mean, we're staying down close there. I mean, we're within 1 or 2 GSDs of our ground control points, and our ground control points we're getting better with them, but usually around a half a 0.05, 0.04 survey feet, and then but our goal was a half an inch, 3/4 inch with these surveys. And we had, like you were talking about with contrasting, when you get into these asphalt surveys, we have to really come in low, but we've overcome some of that by getting thank you, John, we got a better camera. Having that 42 megapixel camera, we don't have to fly as low. With the Phantom, we were flying like 80 feet to get the tightness of that asphalt down.
We really seem to be limited to the same accuracy level that your GPS is located or limited to. So if you can't go out there and survey it and tell the difference, then odds are we're not going to tell too much of the difference with the drone as well. But our ground resolution with our drone system, and we're down to a 1/4 inch. 3/8 of an inch on the ground sampling resolution, especially for these road shots. For earthwork, 1/2 inch to an inch is more than enough. But when you get into asphalt for those contrasts, you need to get down in there to your aggregate side, basically. But it works. If it works, it's fine. There. Oh, okay, so this is doing the road shots again. Just skip it earlier. You're gonna have to do it over there. Oh, no, that's fine. But so with the road shots, if you have long distances and you want a survey area, survey it quickly. Once you draw your brake line in, you can also draw it. So you got your curved brake line. If the road's curving or anything, or the road's widening, you can have it set to where it'll set a road shot every 3 feet until it hits the brake line. So if you have a section where it went from 1 lane to 2 lanes, it'll automatically throw that road shot grid in there, widen it for you. There's a bunch of little little tricks that you can do as well. One of the biggest things with TopoDOT is to be able to use your point cloud to get the information from it that you need as far as visually, and then hide the point cloud to get the design data that you desire as well. As they're taking that data that we just captured, the brake lines, the road shots, we're going to try to create a little terrain real quick. So we use the terrain creation tool called graphical filter. Essentially, all you're going in there is you're creating your filters based on the levels. So you'll have a filter for your breaks, your filter for your spot shots, and all you have to do is associate levels with each one of those categories. We walked John through a little project recently, and I think that was your first time using the software on it, and it came out pretty quick. Excellent. This seems to be the easiest way for us to create a terrain from our data that we've captured. So once you have your graphical filter created, then you just go in and set your graphical filter that you've just created, and it'll go through and look for all the levels that's associated with that filter, and we'll triangulate it. And then now you have a terrain, so just like any other terrain, you go in and you can edit your triangles if you need to, but you can turn them on, off, and you can add your contours, add your minors. Hopefully that just makes it just more aesthetically pleasing from the traditional surveying standpoint than a million points when you have a lot of this. Well, does anybody have any other questions about TopoDOT? We'll get into the drone equipment real quick. Okay. Here's some of the examples of the equipment that we're using for our drone mapping. This Matrice 300 is the main drone that we're using. Justin said we have the P1 camera on it. It's 42 megapixel camera. We also have an upward facing gimbal on it, which enables us to get under bridge decks and survey the bottom side of the bridge deck as well. So we've done a pilot project with TopoDOT Chapter a couple weeks ago in Frankfurt, and we've yet to get the data back from them on it, but the photos turned out amazing, and it makes us to see how well that works. The Phantom 4, this is kind of what we're trying to get put out to some of our construction inspectors on big projects like the one we had in Somerset. If they can get that set up on our contract around $9,000, and we can have our inspectors flying that weekly and uploading that to TopoDOT or to DatuBIM. Then designers, construction, whoever wants to can pull that data into whatever they need to use. The other ones are essentially just our recon drones. This is the Autel Evo. That one's I lost it. Mavic, and that one is the Navi Parrot. Yeah, so what we've done recently, we went away from the base station, and we connected drones to the RTK of the CORS network for RTK, and all of our mapping we use RTK enabled drones. One thing we do have that we're just getting into the LiDAR unit called the L1 for the M300. That's still under investigation. We have an idea. We have a dual gimbal like you see here. We're gonna put the LiDAR unit and the camera on at the same time and produce the model identically. Obviously, there's going to be like a 6-inch offset, but just to see what the comparison is between them. Does anyone fly any drones? Anyone have experience? We got one. Which one do you fly? The Phantom 4 Pro. Are you getting an M300? I got you. You have experience?
We fly the Navi, and we have a couple of the models, and we didn't just go out with your bridge inspection team in their SkyGeo, which is nice for bridge model inspection.
And the S2, the little one, or the big X2?
The S2.
The S2 is awesome for recon, because they'll get into a tighter area. The endurance of that X2 is a lot.
Yeah, we borrowed their X2 and we've been using this for some pretty neat stuff.
And the incident management on the recon side is.
Yeah, last week we were in Eastern Kentucky and I flew it down a creek with overhanging branches that were, I mean, it was crazy and it wouldn't hit one and you could fly it wide as fast as it would go.
Yeah, that's a nice borrow.
Yeah.
This M300 drone, I mean, having that, has a little larger payload, you get a little extra flight time on it. You're going from, give or take a little bit, about 25 minutes to 30, 32 minutes with the M300. There's a little bit further, so you're getting out from, we can see this one in half a mile on the Phantom 4 RTK to the about a mile and a quarter with the M300. Having that little extra range can be beneficial. There's some extra use cases with that, but the standard Phantom 4 RTK is still hard to beat.
Let's go into what we have for our M300. The H20T, it's just well, we don't have the H20T, we have the H20. It's a 20 times optical zoom. We use that essentially for inspected trusses with it. We inspect brick bolts, just things of that nature. The L1 is the entry level in the LiDAR that we just got. We've not got enough experience on it to really intelligently speak on it yet. And the P1, that's the 42 megapixel camera that we use all the time.
And the key to P1 is having that, having that opportunity to change out lenses, because we just got to settle lenses in 24 millimeter to all the way to 50 millimeter lenses. Having that zoom, if we want to get the roadway shots, or if we're just trying to keep safety, it's very handy to have a long term. Just some quick project that we have, some project samples. So just having the overview videos from a recon level, having flights, to be able to zoom in and get some information even on the threads of the bolt, get into the millimeter micro cracking, the construction site progress monitoring, getting into areas that's still grubbing. Just getting the areas that you don't necessarily want to go get up in their business when they're clearing, and you can actually be able to go out and check it and see their progress and maintain a little bit of safety on it as well. Or before you go out there, going out and testing the project and looking around before it. Just a sample project we did for a drainage. I go in and having that 2D map and then overlaying it with some old design files. Next one's, one more. So yeah, the next one's pretty neat. Have issues with trees. We went into some low water bridge crossings and went, Google Earth, you can't see the bridge, and going in and actually flying at 10, 15 feet off the ground, if not lower than that, and just taking hundreds of pictures, getting that 3D model of the bridge under tree canopy was a fun little project. Some things that we've been doing too, doing the virtual public involvement, having the design file, that 3D model, and then trying to mimicking it, which we're still improving it, but having the mimic of the video fly through to where anyone can see what it looks like now versus what it looks like in the future.
So we got this from the designer, the video on the left, and then we went out and flew this, and we tried our best to do a comparison between them. Still a little jerky. We are not expert videographers by any means. So there are tons of folks out there that do a better job videoing than we do, but we really seem to kind of capture the idea that the potential is there with a little bit of practice.
Next is just an example of a 3D model. Interchange, little example point cloud. And then going to one of the questions on asphalt. I did have like a comparison between 400 feet, 200 feet, 100 feet, how that 3D model, getting into the details and how that smooths out, because you will get a lot of noise in your model if you fly too high on these point clouds using PhotoGram. That wraps it up for us. If you have any questions, let us know. We greatly appreciate that we've done it as we went. It's made a lot easier.
I was wondering, do you use your drones at all for environmental purposes, like searching out for potential bat nests or like watersheds for projects, things like that?
We did some watershed stuff on our maintenance facilities for our environmental folks, but that's really all we've been asked to do so far.
Okay.
But
have you used the drone programs for creating points?
You want to speak on that? Yeah. No, we haven't gotten to that point yet. That's something we need to get to. John's gonna put some notes on board. Anyone else? Project. Is there anybody on?
well, thank you all.